recording, ready for our Programming 2 class. And I can get it up on the screen. Take a look at what we're doing. I'm jumping into the grade screen here, and we see we should be done with all of Module 1 now. And, we're supposed to be done with the first lesson, but I didn't do it here yet. So I haven't turned in the first lesson. But this week, October 12th is Sunday, so we're doing 2.02 mathematical operators. So we got into some math in Programming 1. We'll see what we do in Programming 2. Perhaps expand on that. I don't think we have a program this week. I believe next week is our next program. So this should just be another short assignment week. I got totally out of it. I meant to go back to the screen. Mathematical operators. Let's take a look. Python's math operators. We hate to break it to you, but all your math teachers were right. I don't mind hearing that over and over again. Math is used in real life and quite frequently, especially in programming. And we're not simply talking about using Python as a calculator. Select each image to see how math and programming can be combined to do some pretty neat stuff. So, all right, so we see this little game, which kind of looks like they used a Mario game, but they put a dude there. When programming video games, character movement is controlled using math geometric equations. For example, the path a character takes when jumping. Sure, we see that when you have a little character jump, kind of like a parabola. I'm sure there's a lot of math in making that land properly. Absolutely. Course Autumn promotion, 50% off. When planning yearly sales, retail stores rely on math, for example. Programs that use probability to predict when customers will make purchases so they can control their inventory, have the right stuff in the store at the right time using some probability matrices and that kind of stuff. And this looks like a whole bunch of different things going on over here. Programmers use math to create graphical user interfaces, or GUIs, the user's visual display. For example, calculations of available screen space are used to help determine the layout on different screen types. That would be something, because think about it. When you put something out there, even on a web page, people looking at it on phones and all kinds of different shapes of monitors. Some people have huge square monitors, some have long, wide monitors. So I hadn't thought about that. But yeah, you'd have to calculate how to lay it out on different types of monitors based on what you see there. So that's a lot to chew on, I'm sure. Some of the Python operators are familiar ones that you've seen in math class, while others are specific to programming. So let's take a quick Python check, make sure you're able to identify some of the standard math operators. So an exponent. So an exponent uses 2 asterisks. Multiplication is 1 asterisk. So 1 asterisk means multiply these numbers, 3 times 5. 2 asterisks means 2 to the 3rd power, or 8. So that's a good distinction right there to know how an exponent works there. Now, we also used the power command last year, but this is a shortcut. We don't have to use that. We did the import math, and we did the power function where we can raise things to a power. Now we're learning we can just use 2 asterisks and do the same thing without having to do all of that. Division is just a division symbol, a little slash, but 2 is floor division, which is quotient from floor division of 103. It ignores the fraction. 100 divided by 3, floor division, is just the third. Just give me the integer there. Modulo. It sounds like a Spanish name for remainder. But the little percentage sign, 22% 8. So if you divide 8 into 22, you get 16 with a remainder of 6. This just gives you the remainder. So that's what this is saying. Divide 22 by 8 and just tell me the remainder, which is a nice way to write a program to figure out if something's divisible by something. Because if the remainder is 0, you know it's divisible, right? So you could use that in calculating some stuff along that ways. Subtraction, just a minus symbol. Addition, just a plus symbol. So those are pretty straightforward. We know that. But there's a few new ones there. I like the exponent shortcut, just using 2 asterisks for an exponent. But yeah, and then division, we can either grab the quotient or the remainder. So, all right, let's go to page 2. Something tells me our program next week is going to have some math. Programming specific operators. You're probably not as familiar with the two programming specific operators, including floor division and modulo. No, we haven't ever played with that. That's new. Let's examine these in more detail here. Floor division. The // operator performs floor division and will return the quotient as a whole number without the decimals. Example, how many bundles can you sell? Right. So your online shop offers special pricing on bundled packages of 15 items. Currently, you have 50 items in stock. You could use floor division to figure out how many 15 items packages you can offer with your current inventory. Because when you divide 15 into 50, it's 3. 3 times 15 is 45. There's a remainder of 5. So you know you could sell 3 of these 15 package bundles, and you'd have 5 packages left over. So in Python, total items equal 50, package equal 15, print total items // and again, I want to play with it and actually program in the window. I know they do the little screenshot of the Python window, but let's take it and actually put it in there. Did it not copy? I don't think it copied. Copy. All right, so when we run the program, there it is, a 3. So if we play with those numbers, and let's say 500 is 500. How many times will 15 go into 500? 33. And just cuts off the remainder. Doesn't tell us. It's just the whole quotient as an integer. So this shows you the output is 3 on 15 into 50. In Python, the order of operations is similar to that in mathematics. If you need a quick refresher, head to the reference section for a review. Yeah, order of operations, similar. It should be exactly the same, not just similar, but the order of operations should work in Python as well. So again, the reference section's got order of operations in there if you need a review of that. Data types matter. That we're pretty sure about. Now that you're familiar with math in Python, it's important to know how to make conversions. When programming, there are times we need to convert values between types in order to work with the values in a different way, like choosing float or integer and string matters. Sometimes in your wallet. If the register at your favorite shop calculated the price using integers, customers would be throwing money away because it would round up to the nearest dollar, right? Even if your total is $2.50, you'd be paying $3. Converting to float would not only make the prices more accurate, it'd keep the customers happy. I don't want to keep donating extra money to you. You need to know when a value is a floating point, when it's an integer, or when it's just a string, because a program, including the one running the cash register, is only as good as its programmer. So this flow chart helps you figure it out. Will I do math with this value? If not, it's just a string. You got a 52, maybe that's an apartment number. It's nothing you're going to do math with. It is a number, but we're going to treat it like a string because it's just like an apartment number or something. But if we are going to do math with it, does it contain a decimal point? Or I like to say, could it possibly contain a decimal point? It might not right now, but there could be a different number you enter and it would need a decimal point. So if so, make it a float. If it's never going to have a decimal point, it's an integer. So test your understanding of the differences. Oh, I think we can nail this. Let's see this. All right, the total number of shipments in an order. So is that going to be an integer, a float? Here, I'll open up the chat too. So is that going to be an integer, a float, or a string? The total number of shipments in an order. So I guess first you got to think, would you do math with that? Yeah, you might do math with that because you might add up the total number of shipments you sent out. So now is that going to be an integer or is that going to be a float? Could it possibly have a decimal? Total number of shipments in an order. Could we ship out 3.5 orders? No, that's good. That's going to be an integer for sure. How about the number of points remaining until a reward coupon? Yeah, we might need to have more information on that. Can you earn partial points? Without telling us that, we're going to assume that's an integer, I guess, because we don't know. Can you earn half points? Let's see. Yeah, it's assuming it's just an integer. How about 27.93? Is there any question there? 27.93? Yeah, there's not really a question there. That's a float value. How about inventory for a store item? Hey, how many cans of Coke we got back there? Right? That's definitely not going to be a string value because we may do some math with that. And we're not going to have 0.78 cans back there. How about an average customer rating of 4.75 stars? Now, the way the 4.75 is definitely using math. If we just think about your rating, okay, that could be a string, but since that's a calculated thing based on all of everything, that's got to be something you're doing math with. It's a float. Customer's address. Hey, we talked about this as an example, right? Your address, whatever number your house is, you're never going to multiply that or divide it or anything like that. That's just treated like a letter. Item number 2BZ869K36. I should Google that, see what comes up as an item number. Oh, well, that's got B's and Z's and K's in it. Definitely going to be considered a string when you do. There's no way you could add that to anything if you wanted to. Because it's got like, unless you say it's like hexadecimal or something weird like that. Hexadecimal wouldn't have C's or K's. Time of purchase. Oh, that's an interesting one. Because time is a number, right? Purchased at 1:38. But do we do any math with that? I think it's just a string, right? It's just a string value of what time you purchase them. Customer username. Okay, yeah. Bob +3. No, it's no math. That's a string. The state tax rate. Well, that's definitely going to be some math on the tax. And hopefully it's going to be a float, not an integer. We don't want to be taxed at like 100% or nothing like a 1. 3147. Well, unless that's an address, definitely an integer. Total shipping cost. Well, anything that has a cost is generally not going to be just an integer because it could have some decimal in there. So really the only strings are the address, the item number, time of purchase, customer username. But that wasn't a real challenge. We've got that. Converting data types. Music. It's fun to listen to, but a pain to organize, especially digitally. Some audio formats like MP3s are commonly accepted by any music player, like iTunes or Google Music, but every now and then you'll run into an audio format that cannot be recognized. What's an audio file to do? Well, convert it, of course. So this same concept is true in programming. In Python, certain data types will automatically be understood. But many times you'll also need to convert the data for the program to function as you intend. So knowing how and when to convert data types give you added functionality and flexibility to your programs. Python will handle certain conversions automatically. For example, an expression with both floats and integers will automatically convert to a common type. So sum of float and integer will automatically be a float, right? Because if it made it just an integer, you'd lose some of the accuracy. We'll go back to our Python window and see if that copied. Yeah, that copied. So if we print 20.5 plus 4, 4 is an integer. This is a float. When we run it, it's 24.5. It automatically gives you a float as the output, which makes sense because it's not going to be accurate if we just cut it off and make it an integer. So yeah, 24.5. Python has a number of built-in functions you can use. So to convert between number types, data types, or strings, call the type name as a function. So let's look at some common conversions and when you might use them. So we might want to convert an integer to a float. Convert an integer to a float. To do this conversion, use the float function and add an integer inside the parentheses. So audio count equals 17, and if we print it as a float, in our Python idle window, print it as a float, it's going to print 17.0. because we converted it. It started out as just an integer, which it would have been treated as an integer, but we told it, hey, by the way, it's possible in the future this might need a decimal, so let's go ahead and make it a decimal number now. So it's a float. About integer, converting floats to integers. We just use the integer function and put a float value in it. So if we set a variable audio seconds to 180.3, so this song is 180.3 seconds. We'll just consider it 180 seconds. We're not going to worry about the 0.3 of a second that the song lasts. 180 seconds is good enough. So we converted it to an integer, and it just rounded. Convert an integer will round to a whole number. Of course, 0.3 rounds down because it's less than half. So, and you might do that to save memory, because this takes 2 extra characters to save things as a float every time you use it. You need a decimal point and then a number, or possibly more numbers. A string. Sometimes you may need to convert number types to strings. So to do this, we use the string function. Now, we know in a print statement, we've had to do that. Like when we print something, we have to print strings and numbers together. We have to tell it, hey, I know this is a number, but treat it like a string and just print it. So this type of conversion comes in handy often, since Python is unable to concatenate strings and integers or strings and floats. Converting these types to strings allows them to be concatenated, or we can put them in the same print statement. So if we put them here, Shopper Benson purchases equal 20. Here, let's make this a little wider. Congratulations, Shopper, which would be Benson, right? You just completed string purchases. Let's run that. Congratulations, Benson, you just completed 20 purchases because this was an integer and qualified for a free audio download. But we had to convert that to a string to be able to concatenate it with these other strings and print it. So, and we use that a lot back in programming 1 as well, the string function there. All right, page 5. Math with lists. And we used lists some last year too, so this is a little bit of a review. When it comes to shopping, you expect that items of the same type will be in a certain order. They'll be in order by size, by type, by price, etc. In many programming languages, data of the same type is organized using arrays, but Python generally uses lists instead of arrays. So if you hear of arrays in programming, other languages use those. You can use lists to perform simple and complex mathematical functions across data of the same type. This might come in handy if you need to increase the price of certain items or the quantity of a certain size. So let's use the min and max functions to find the minimum and the maximum numbers in a list. So we're looking for the lowest price. We get a list of all, put them all on the list, and ask for the minimum number or the max number with that min command. So we have this list that was created, and we named it my numbers. Remember, lists use those square parentheses. So put it in square parentheses with commas in between them. We have a list 1, 3, 4, 5, 6. And we want to print the maximum number and print the minimum number using the max and min commands and putting the name of the list inside there. So let's I'll copy the word Python up there. There we go. Okay, run the program. Maximum number list is 6. Minimum number list is 1. And just to make sure it's really looking at the maximum, let's put a bigger number back here. 312. I didn't put it at the end because it's like, is max just going to the end and taking us the biggest number down there? This is a good test. We'll put a 12 in the middle. Nope, it does check the value because since the maximum number is 12. 12, even though it's in the middle of the list, it's not just the last number of the list. So I like to kind of test those things just to make sure it's working the way we think it's working. All right. So, yeah, that shows the same thing there. Math and shopping go hand in hand. especially since you can write programs to do all kinds of calculations. So now it's your turn to write some code using Python's built-in functions and math operators. So here's a Python guided activity. Read the code, try to predict the output. All right, so this says it's a program to find the highest and lowest price. There's our defined main functions. Here's a list called item prices with 5 prices in here that are all float values: 7.00, 4.50, 2067, 340, 1590. Print, the largest number in the list is, and look, instead of a plus sign, you can use a comma, because normally we put a plus to concatenate. A comma does the same thing. In fact, I'm going to change one to a plus and see what happens. Just for fun. Oh, that gave me an error. Can't convert float to string implicitly. I wonder if we give an error the way it was. They put it back, make sure. All right, run program. Okay, with both of them with commas, it works. It didn't work when I made it a plus symbol. I wonder if we make it a plus symbol, if we have to use the string then. Let's put the string around it. Oh, wow, then it works. So you don't have to convert it to a string if you use the comma. If you use the plus, we have to convert it to a string. All right, so we're learning something right there just by playing with their program. So a comma doesn't require you to use the string function, because it works just like that. Explore by changing the values of that in prices. Okay, we're going to make this one $84, and this one just going to be $1.90. But now you have $84.50 is the biggest one, and $1.90 is the smallest. Just changing the values. All right, let's look at the second slide. Merging lists. Oh, this is cool. So we got a list that's 1, 2, 3, and a list that's 4, 5, 6, and we want to print list 1 plus list 2. There it is, 1, 2, 3, 4, 5, 6. And it prints them as a list. It put them in brackets automatically. So the plus symbol can be used to merge 2 lists. Just add them together, concatenate them. It says explore this by adding a third list. Okay, well, let's add another list. List 3 equals bracket. I wonder if I make it a float value, what we'll do. What if it'll convert everything to a float, or just add this to the other one? So there, we made a third list. So let's add the third list on there, plus list 3, and see what it does. See if it converts everything or what. It did not convert everything to float. It left them like they are and just printed these. And it may be treating them all as a string, possibly, because we haven't done any math with them. But it just added them right to it. All right. Slide 3. List 1 times 2. Oh. So it is treating them as a string, because it did not do math. It did not double them. It considers these are just like letters. Because if we just change the 2 to a P, oh, now P is not defined. Okay. It did not like it as a well, P, no. Okay. They all have to be the same type. That's the thing. In a list, they all have to be the same type. So I wonder if I change these all to letters. P, Y, P. I wonder if there's an error now. Yes, there is. Okay. Interesting. Playing with it and learning what works and what doesn't. It says explore by repeating the second list. So, okay, let's print list 2 times 3 times. We'll go 3 times with ours. Yeah, there it is. 4, 5, 6, 4, 5, 6, 4, 5, 6. A list can also be repeated using the multiply operator. So repeating a list with the multiply. Put extra space so it looks like the other one. Let's look at slide 4. Okay, so we have these store prices 1 and store prices 2. And $7, oh, the price went up 5 cents. The price went up $1. Price went down. Price went down. Price went down. Print the largest number from the combined lists. Okay, so we use the print and the max command and say, put the lists together and give me the largest number. Or put the list together and give me the smallest number from the program. 2067. Yeah, that would be the largest number up there. And 3.4 is the smallest number. Wait a minute. It says your code runs and that's not quite the output we're looking for. Oh, it says try to predict the output. Create a third list. They want us to create a third list. Okay. I'm like, what's a complaint about? We just ran the program. Price is 3 equals list. And they want to use the following prices: 3.0, 30.50, 9.0, 10.25, and 3.75. Find the largest and smallest number from the combined lists. So we would have to add our list to their print statements. Store price is 3. Okay, let's run it. Oh, what happened? Line undefined. Can't assign to function call. There seems to be an error. What did we miss? What did I do? Comma, 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 comma. There's periods. Store prices. It's indented the same. Did I type this exactly correct? Store prices 3. Oh, I put an equals instead of a plus. That's it. Okay, I knew somewhere something had to be wrong. There it is, 30, 50, and 3. We had a smaller value right here and a larger value right there. Combining the powers of math and Python allows users to calculate and combine lists quickly. All right, yep, something real simple. I used an equal instead of a plus. Did you know when discussing arrays in Python, you may hear the term NumPy? NumPy, N-U-M-P-Y. NumPy, pronounced NumPy. Okay, NumPy is a library that can be installed and used in Python. Wow. It's a collection of modules or files. Like we import math, we can import NumPy. Once installed, NumPy allows programmers to work with real arrays in Python, making mathematical calculations more efficient. So you can use arrays if you import NumPy. Otherwise, we could just use lists. So if you like arrays, you can still use arrays in Python. Interesting. NumPy. All right. Page 6 should just say, read the lesson, practice, and do the quiz. Here's this week's assignment. Select the operator for division. Select the math statement that's true. Oh, that's a good one. Let's see. In the following code, the input will require which standard data type? Float, integer, tuple, or string? Okay. In the following code, what output will be produced when you call the main function? So what's it going to print, basically? That's what I want to know. And you've been asked to create a program for an online store that sells their items in bundles of 5. Select the appropriate code to display how many bundles are available. All right, that's that command that we looked at back at the beginning page. So, interesting stuff there. So, all right, learned a few new math commands we can do with Python. I'm sure we'll get to play with those next week in our program, but this week, just 5 questions over it. So make sure you understand what it's asking there, how to use the max min, all that good stuff. And that's all we got for the week. So, all right, fellas, have a great week. We'll see you in algebra. Oh, wait a minute. Are you in algebra today or tomorrow? Today. If it's tomorrow, I won't see you because tomorrow's PSAT day. So I'll have just a video and you can just read the lesson and do the work. Because we're not going to meet at all this week in 3 days. So, all right, guys, have a great one.